This is the video lesson for 10.1 for Algebra 2, Exploring Conic Sections. So the object of this section is to graph and identify conic sections. So what is a conic section? Well, it's basically a curve that you get by intersecting a plane and a double cone. So this green thing here is a double cone. Picture two like ice cream cones touching at the tip. This is a double cone. If you change the inclination of the plane, right, which way you cut through, so you can imagine this plane cutting through this double cone in any spot. If it's just parallel to the base here, it becomes a circle. If you just cut just at a diagonal, just one of the edges, you get a parabola. If you cut just one of the cones directly through, but on a diagonal, you get an ellipse. And if you cut perpendicular to the base here, you get what is called a hyperbola. So it's like a parabola over two sides of a parabola. So those are conic sections. And conic, right, the word cone. So if you picture two cones and then a plane cutting through, it's really these curves. It's a circle, parabola, ellipse, and hyperbola. Okay, so moving on, let's look at the first problem. We have an equation with x and y, where the x is squared, the y is squared, and it is asking what are the lines of, what's the graph, and then what are the lines of symmetry, and then what are the domain and the range. So we're going to use a table here. So we're just going to plug in some values of x and figure out what y is, and then plot the points. So we can see here, we have x squared. So what I'm going to pick is, first let's do zeros. So that will make our life easy. Let's pick x as 0. So if we plugged in 0 here, right, this goes away. So it would just be y squared equals 25. So if we took the square root of both sides, we get y equals plus or minus 5. So as you can see, this is not a function because we have one value of x actually gives us two values of y. So we get 2 points out of that. So we have 0, 5 is a point we can plug in, which is 1, 2, 3, 4, 5 here. And then 0, negative 5. So x is still, so you can see that fails the vertical line test already. It's not a function. Now let's plug in 0, y is 0. And then if we plugged in y is 0, we would plug that in here, and that would go away. So we would just have x squared equals 25. And the same thing happens when we take the square root of both sides. X is plus or minus 5. So when we have two values, when y is 0, we have two different values of x for that, 5 and negative 5. So like when we can plot, oh, I didn't write this, negative 5, here's all our points, 5, 0, which is 3, 4, 5 here, and then negative 5, 0 is here. Okay, now let's pick x is 4. So this would be 4 squared plus y squared equals 25 squared. Sorry, just 25. 16 plus y squared equals 25. If we subtract 16 from both sides, we get y squared equals 9. And so if we take the square root of that, we get y equals plus or minus 3. And then that would work also if y is 4. So what happens is, when x is 4, you get two y's, 3 and negative 3. But since they're interchangeable, if y is 4, you also get 3, negative 3. So we have 4 more points. 4, 3, 4, negative 3, 3, 4, and negative 3, 4. Right, because this is, I added these 2 points too, because if we had made this a 4 squared and this was an x squared, right, this would just become 16, we'd subtract, and this would be 9. This would just be x squared equals 9. So I'm just trying to save a little time here, but you can take time if you don't understand that. 4, 3, 4, negative 3. This also works with negative 4, right? If this had been negative 4 squared, we would have got the same thing. So we also have negative 4, 3, and negative 4, negative 3. Negative 4, 3, negative 4, negative 3, which means this also works. Negative 3, negative 4, and negative 3. Sorry, positive 3, negative 4. Okay, so then this is 3, 4, 3, negative 4, negative 3, negative 4, and negative 3, oops, this is still -3, -3, 4, and -3, -4. There we go. Okay, so what's happening here? I think that's enough points to see that this is a circle. Okay, so that is the graph of x squared plus y squared equals 25. Lines of symmetry just means like what is a line you can draw that that will be symmetric on both sides? Well, with a circle, right, if you just draw any line through the origin here, those are going to be symmetric. So this is basically lines of symmetry, any line that goes through the origin. So there's an infinite amount. I shouldn't write it like that. Infinite amount. Okay, and then what are the domain and range? Well, remember, domain are the x's that are on our graph. So we have there's no, so if we're looking just at the x-axis, the values of x, so as we're coming in from negative infinity, there's no, the circle's not on anywhere until you hit -5. So our domain is going to start at -5, and it includes -5. And then, so then my x's go from -5, -4, -3, all the way to 0, and they keep coming until we get to 5, and then they don't go further than 5, right? So we have values of y in this range here. Sorry, on this domain from -5 to 5. And we do include 5, so that's the domain. Okay, and that's just talking about the x values here. So on the domain, right, 1 is in the domain. So that means this value of x, if we plug in 1 for x, we get a value of y. That's all this is asking. And so like 6 is not in the domain, because over here, if we plug in x is 6, there's no y here. There's nothing to go to. The graph is not here. So it's basically where, for what values of x can you plug it in and get a value of y? And it's just these guys here. And then the range is the opposite of that with the x, where we just pay attention to the y-axis here. And so we're coming in from negative infinity. There's no, our function isn't here yet until we hit -5, and that is included. So we make the little bracket, and then we have y values all the way from -5 up to 5, and then anything above 5 we have no y values for. So the domain and the range here are actually the same, and it does include 5. So that is the answer to that question. So you can try one on your own. Plug in some values and see if you notice the pattern. I'll give you a little time. You can actually just think about it. This is a circle, equation for a circle, which is the form x squared plus y squared. And then it equals this number, which is r squared, which is the radius of the circle. So the radius here is 5. So this is a circle of radius 5. So look at this and think, what is this going to be? What kind of circle is this going to be? What's the radius going to be? And then you check a couple points and then just draw it. Lines of symmetry are going to be the same because it's a circle. And then see if you can figure out the domain and range. All right, press pause and check back for the solution. Okay, and hopefully you realize that this was a circle with radius 3, since that is the square root of 9. If you plug in 3 for x, if you plug in 0 for y, you get 3, -3 for x. If you plug 0 for x, you get 3, -3 for y. And then you can plug in maybe plug in a 1, and you can get other values to put on the circle. This is a circle with radius 3. All lines of symmetry are all lines that go through the origin. And then the domain here doesn't start until -3 and includes it, and then ends at 3. And then the range is the same thing. Starts at -3, ends at 3. Okay. Moving on. So that was a circle, just introducing some conic sections. This is a little bit different, right? Remember I said a circle is going to be x squared plus y squared. If you put a coefficient on your x and y, it's going to change a little bit. So let's see what happens here if we plug in some values of x and y to get some points. All right, so let's start with our zeros. When x is 0, right, this goes away, and we have 16y squared equals 144. And if we divide both sides by 16, and then take the square root, you can take the square root of the top and the bottom. So this becomes plus or minus 12 over 4, which is 3. So plus or minus 3. So we have 0, 3, 0, negative 3. Then if we plug in 0 for y, this goes away. We have 9x squared equals 144. X squared equals 144 over 9. So x equals plus or minus 12 over 3, which is 4. So plus or minus 4. So 0, 0, 4, negative 4. And you can kind of see where this is going. Let's try plugging in 3 for x here. So 9. And negative 3 would work too. So let's do negative 3. And this is going to be the same thing, right? Because we're squaring the 3, so we get the same number. 9 times 9 plus 16y squared equals 144. So that's 81. So let's subtract 81 from both sides. Okay, if you subtract 81 from 144, you get 63, which is really close to 64. And then divide by 16. So this is going to be about, if you take the square root of both of these, right? This is about 8, and this is 4. So this is going to be about plus or minus 2. And I think for our purposes in graphing, we're close enough here. So let's have 3, negative 3. It's going to be slightly less than 2, so let's put it just less than 2, just less than 2, and then over on this side too. Okay, we're really just trying to get a gist of this, and the purpose of this is just so you can see if this is going to be an ellipse. So it's not a perfect circle. Okay, and that's because these coefficients here make it a little lopsided, right? One side goes higher than the other, and it's kind of like an ellipse. Not kind of like an ellipse, it is an ellipse. Okay, so that is an ellipse. So this is when a circle, it's going to be a circle when your coefficients are the same on both the x squared and the y squared, but it's going to be an ellipse if the coefficients are different on the x squared and the y squared. So we know the next one's going to be an ellipse. See if you can figure out what that graph looks like. Oh wait, I didn't do the lines of symmetry. Okay, sorry. Let's answer the question, right? We just did the graph. It takes a long time to do that. Lines of symmetry in this case are just going to, there's just going to be 2. One through the y-axis, right? Because this side is symmetric with this side. And then one through the x-axis. This side's symmetric with that side. So our lines of symmetry are just y equals 0 and x equals 0. And then the range and domain are going to be done a little bit different. Remember, domain, we only care about the x. It's going to include the endpoints. And domain, we're only on the x-axis. So this is my negative 4 all the way to 4. That gives us values there. So this is negative 4 to 4. It includes them. And then the range is going to be a little different, but they're going to be included. And that's going to go from negative 3 to 3. Okay. So now try this next one on your own. Let's give you a little space. Plug in your values. At least try to see, and now that you know it's an ellipse, see where it's going to go. Plug in 0 for y, plug in 0 for x, and see your answer. And then you can have your x-intercepts, your y-intercepts, and then you can draw your ellipse. Lines of symmetry are going to be the same. And then write your domain and range. So this shouldn't be too bad. Press pause, try that on your own, and then check back for the solutions. Okay, so here's the graph. When y was equal to 0, it was easy to find plus or minus 3 as your x-intercepts. Y equals 0, sorry, x equals 0. Didn't give us a perfect number, integer, but that doesn't happen a lot with these. So it's about plus or minus 4.24, or 3 root 3. So when you plot those points, make your ellipse. That's your graph. Lines of symmetry were the same, the axes. And then domain was negative 3 to 3, and then range was negative 3 root 2 to positive 3 root 2. Hopefully you got that. Okay, and moving on. Last thing we do need to learn about is hyperbolas. And this is just for just knowing we're not actually going to get to the section on this. But this is just an introduction, so you know these exist when you do get to these in later math classes. So The other two we learned, right? The circle and the ellipse are probably you're pretty familiar with, right? Circle, ellipse, like an oval. And you do also know parabola from our work with quadratic functions. But you have not encountered this one before, which is a hyperbola. And it's unique because it consists of two separate curves called branches. So this side is a parabola and this side is a parabola. And those equations come when your x and y, when you're subtracting one of your x squareds and y squareds. So then then it's kind of like a reflection of both. So we can see what the graph of that looks like. And here it's a nice, easy one to work with. Let's just draw a table. When x is 0, negative y squared equals 9. X never equals 0. We're actually never going to cross the y-axis. And then if we plug in y equals 0, we just get x squared equals 9, so we get plus or minus 3. So we're going to have here and here. So that means our hyperbola is going to look something like that. So then let's look at values of, oops. Oh, I thought that would erase. I guess this is an ability, sorry. Let's just erase those. Okay, so that's what we're looking for. And let's plug in, since this is my two vertices, let's then look at, this is 3, so let's look at 5. I think that'll make the math better. So let's check out plus or minus 5. Since we're squaring it, it's going to give us the same y values. So 5 squared minus y squared equals 9. This is 25. Let's subtract 9 from both sides and add y squared to both sides. And then here we go, 16 equals y squared. There we go. So y is going to be plus or minus 4. Okay, so we have a 5, 4, 1, 2, 3, 4. And then negative 4. And then we also have a negative 5 and a positive 4 and a negative 4. And so our graph will look like something like this. So it's just a double parabola. Exciting stuff. Okay, and so try this one on your own. Figure out which one needs to be 0, which one can be 0, which one can't be. Plot your 2 points, that'll start your 2 vertices. And then probably I'd say pick the other one to be 3, because then it'll make a 9, and when you subtract, 5, because then when you subtract, when you subtract 16 from 25, you'll get 9, so you can get your 3. Okay, so try that, check back for the solution, and then we'll be done. Oh, except we're not done, because again, I forgot to do lines of symmetry and domain and range. Sorry. Okay, line of symmetry, there's going to be 2. Right here is one, and here's one. Again, origins. Axes. So x equals 0 and y equals 0. And then the domain and range are a little wonky. Let's go through them. It'll maybe help us understand domain and range a little bit better. Here, the domain, okay, again, we are only looking at x values on the x-axis. So starting from negative infinity, we are going to hit values, right? Because this is going to go on forever this way and forever this way. So negative infinity is in the domain all the way up until we hit this negative 3. Then these numbers here on the number line from negative 3 to 3 are not on the domain. But then once we hit 3, the rest is on the domain. So our domain is going to be a little different. Here we're going to start at negative infinity, and we put the parentheses because it's not included. Negative infinity is not actually a number. And it stops at negative 3, and it's including negative 3. And then we move, and then it doesn't start up again until 3, which is included, and goes until infinity. And then we close parentheses. So the domain is from negative infinity to negative 3, and then again from 3 to infinity. And then the range, let's look at this range here, right? This is going down, again, if we're down in negative infinity, since this is going down forever, this range is included. Range is included all the way. The range is everything. So all real numbers is the range. You can do this or you can do this. Okay, sorry about that. Now you can try this one, or we can go over it in a minute. Okay, so hopefully you plugged in 0 for y and then 5 plus or minus 5 for x and got those 6 points and then made your hyperbola. The lines of symmetry again were x equals 0, y equals 0. And then the domain was from a negative infinity to negative 4. And then again from 4 to infinity. And then the range was all real numbers. Okay, here are your practice problems. Enjoy.